Okay. So our agenda is going to be, I'm going to level set. I know there's a lot of people on the Zoom, so we're just going to make sure everybody's on the same page, and then we'll go into how people build images today, what challenges they face, and then I'll talk about Cloud Native Buildpacks, which is the heart of the talk, and show you a little bit of a demo. So this should look pretty familiar to people. You know, you start off with code, you build a jar, and you deploy that to some VM where somebody has, just making sure everybody can hear me right. Someone has prepared that VM. There's an operations team who's responsible for upgrading that operating system, making sure any middleware, whether it's just a JRE or an app server, whatever you need is cared for, and that your app has runtime, right? And so that requires a lot of work, and the paradigm is changing. Oops. Sorry. All right, the paradigm is changing. And so Kubernetes is quickly becoming the platform of choice. And it's shifting things to the left, right? So the operations team is now responsible for a lower level of abstraction, and we get this higher level of container abstraction, which means that where we used to just build our deployable artifact, now we become responsible for building an image, and we have to own, as developers, the only responsibility of packaging in the middleware and the operating system into the image. So this really begs the question that, you know, if the sweat and tears that we were experiencing farther right on this flow are going to shift left, or if we can foresee that and learn good lessons, maybe we can prevent that and make it an easier process for ourselves. So that's really the question at hand. So what are some common approaches that people are using for building images? One is Dockerfile. So Dockerfile it's basically a script that you write whatever you want, right? So it can be very powerful. It works for any kind of application. You execute it with the Docker command. But because it's so loose and you know, it's not, you write it yourself, essentially, right? It's all do it yourself. So all of the responsibility is on you. The responsibility of figuring out what are the best practices, how to make it efficient, how to make it safe, how to support the different components that you're building in. And because it's very difficult to share that across teams or across an enterprise, it really creates this hotbed for snowflakes or black boxes, which is difficult for the organization to manage in the long run. So we want to look for a higher level abstraction. For Java, one great choice is Jib. This is, if you're using this, you're in a good spot. It builds quickly. There's no local Docker dependency. You can just, you know, you write the command to it, or you can put configurations into your Maven or Gradle file. Where it falls a little short is that it doesn't have a centralized mechanism for governance, for updating, to have a little more visibility about the different versions of things in images. So over time and at scale, you're still going to find a lot of variance across your images, and that's going to increase the risk of the estate, right? So this is where Cloud Native Buildpacks can help us. So this is a project that was initiated by Pivotal and Heroku 2 years ago, but Pivotal and Heroku have a nearly 10-year history of building and supporting enterprise-grade build packs. So all of that knowledge and all of that code base can be taken and tailored to work with Kubernetes. So now the goal is to have a very well-defined platform to build pack API contract for taking source code and producing Docker images that can then be deployed, stored in any registry of your choice, and deployed on any Docker runtime. So let's look at it by example. I think that's probably the easiest way to understand how Cloud Native Buildpacks work. So this is a command that would take source code and produce an image. So let's walk through it. Number one, you've got Kpack. Kpack is a CLI for using Cloud Native Buildpacks. It's not the only tool. There's other tools, and we'll talk about a few of them. I'll show you a few for user experiences, but Kpack is sort of the reference CLI. So we're telling Kpack that where our source code is, right? Because the input for this process is your source code. So we have a git clone of our repository locally. We also need the base image to use to build this container image for our application. So we provide that as well. That's the run image parameter. This, we're using a base image that's provided by Cloud Foundry. These are on Docker Hub. They can be pulled. They're open source. They're open on Docker Hub, and there's other choices. Heroku provides some as well. Of course, you can provide your own and simply provide it at this parameter. And then the last set of parameters is a set of ordered build packs. So here you can already see some improvements over the last generation of build packs, where these, rather than being one monolithic Java build pack, now we have modularized the Java build pack. And so it's easier to mix and match. It's easier to introduce your own at a certain point. They're easier to maintain, et cetera, right? So, but these are going to be applied in order on that base image, and the end result will be a Docker image. So this is a lot to type. Nobody wants to type this much. And really the run image in all of the build packs and the ordering of those build packs is something that we're going to reuse across all of our applications. So what the Cloud Native Buildpacks project proposes and does is to package all of that information, that metadata and those references, into an image called a builder. So now you only have to reference the builder, and as long as you have the same code and the same builder version, you will always produce the same image. But even that is a bit long-winded. So what we can do is set that builder as our default builder. It's probably the one we're going to be using the most. And we can cd into that directory with our code. And so that becomes a very, very simple pack build cool app. In this case, our image name is going to be cool app. And the great thing about this is that it works for any framework that the builders support, whether it's Java or Go or Ruby or Python, etc. You can use the same mechanism. So what's in this builder exactly? We've mentioned already that it contains a reference to the base image to use, and it contains a set of build packs. You can see that this particular builder that we're using supports several different languages: Node, Go, .NET, and Java. And you can see on the upper right that Pack actually provides us a command called inspect builder that helps us understand what's inside of our builders. So once the image is produced, where does it go? So the image by default is uploaded to our local Docker daemon. And you can see here that not only is the cool app image in the Docker daemon locally, but also the Cloud Foundry builder and the run image have been pulled from Docker Hub, and they're stored locally as well. So our second build and subsequent builds will be faster. If you want to publish your application image to a remote repository, you can do that as well. You use the publish flag and you're providing the credentials. Just like Pack provides the inspect builder command, it also provides an inspect command for the image. So here we can see that from that builder, using our source code, the precise list of build packs that were actually applied and the versions. So we have a lot of transparency into what exactly are the contents of all of our images, which is a great feature to have at small scale and at large scale in particular. So we've talked about these two stages of part of the process of building an image: the detection, which is examining the list of build packs and the base image and coming up with a build plan. How am I going to build this image? And then the actual build stage, which is the execution of that build patch, of that build plan. There's a few other stages. We have, at the end, when you export the image is exported in a layered manner, and the layers are cached. And so on the subsequent builds, we can take advantage of an analysis between the time that the build plan is determined and the time that it's applied to find opportunities to optimize and reuse layers from a previous build. So this becomes, number one, very fast to rebuild because you're only updating, you're leveraging things that you've cached before, but it's also very safe because rather than, as you would do probably with Dockerfile, unless you put a lot of work into your Dockerfile, instead of rebuilding everything, you only rebuild what needs to actually change and everything else stays the same. So it's faster and safer. Now we've been talking about Pack mostly as the tool for executing Cloud Native Buildpacks. Pack is one choice, but there are others. And so one example is Kpack. And Kpack provides the same functionality, but it's installed as a service on a Kubernetes cluster. So this is a way of sort of getting back that hosted experience that Heroku and Cloud Foundry provided with their build packs. So now at your enterprise, you can install Kpack and you can point Kpack to your source code on your Bitbucket or your Git repo, and you can point it to the builders you want to use. And any change to either of those, whether it's a Git commit to new code or whether it's a new builder or a new run image that's been released that you provide, either of those will be detected by Kpack, and Kpack will automatically go and update the image on your Docker registry. So that's pretty cool. like I said, there's a few others. I'm going to show you the first three: Kpack, Spring Boot, and Kpack. But there are others, other platforms, and the ecosystem is growing. So let's go to the demo. All right. So let's start by just looking at the Kpack command. So we talked about Kpack build. We showed a slide using Kpack build and the syntax of that. We talked about Kpack inspect image, Kpack inspect builder. What about other builders that you might want to use? Kpack actually has this great command, Kpack suggest builders. So we can see other builders that we might want to use, and you can see you might choose them based on the language of your application. Here on this, we've got some Docker images already built. Because time is so short, I only have 20 minutes, so I've already pre-built the cool app for the first time. So what I want to show you instead is this ability to rebase the image by choosing a version pinned run image. So this would be a simulation of a case where you have an image, but maybe there was a case like Heartbleed and there was a new base image released, and you want to just change out that sort of OS layer in your image. So here you can run this rebase command, and it very efficiently changes the pointer to the base image. So Kpack is doing it as a one-off, and Kpack running as a service on Kubernetes could do this for all of your images. So it would be a very, very effective way of beating a situation like that. But you can see very quickly it rebases the image. And we can look at our Docker images again. And you can see that, number one, it's downloaded that base image from Docker Hub, the one that we requested, and it built a new image with a new SHA with this new base. So now let's turn our attention to Spring Boot. Spring Boot, since version 2.3.0 milestone 1, has built-in support for Cloud Native Buildpacks. So in this application, I happen to be using version 2.3.0 milestone 2, which is later than that. So the Maven and Gradle plugins in this version have support for Cloud Native Buildpacks. So I can simply type Spring Boot build image, and Maven will build my application. First, it'll build the jar file, and then it'll use that, it'll orchestrate that Cloud Native Buildpack lifecycle on that jar file, execute all of the build packs on it, and produce the OCI image. And just like Kpack did, it's going to store it in the local Docker daemon. So you can see here already that it's starting to pull. Now this is interesting. I said earlier that I already had the builder in my local Docker daemon, and you can see here that Spring Boot is pulling a different one, and that's because Spring Boot pins the version of the builder on this one, 0053, whereas Kpack doesn't pin it on a particular version, and so because I didn't specify another version, it just pulled the latest. So this one's a little bit older, but that's, you know, that's something fundamental to Spring, the idea of validating versions that work with each other. So Spring Boot 2.3.0 milestone 2 is pinning this 0053 version of the builder. So it pulls it down, but then it runs through that same life cycle that you've seen, where it detects that it wants, it needs to use all of these build packs. Notice that before we were using 7 of 13, and now we're using 6 of 13. That's because it built the jar file first, so it doesn't need the life cycle to build the jar file. So there's one less that we need, and it goes through all of the same build stage, and then it exports, and it's reusing cache, all of that good stuff. And by the end of this, we can look at our image, and also it uses the version, the name of the app and the version in the POM file. So rather than latest, again with Kpack, we didn't specify any version for any tag for the image, but Spring Boot will by default choose the artifact version for the image. So this is our boot build 1. And if we compare this to the image built by Kpack, you'll see that Kpack, for example, uses version 1.2.14 of the OpenJDK build pack, whereas boot used an older one, 1 to 11, and that's because it's pinning to that older version of the builder. So the SHAs for these two are going to be different, but you can ensure that the SHA will always be the same of the image that you build by making sure that you use the same version of the builder throughout your workflow. So I could use Kpack later and just make sure that I'm using the same version of the builder. So I'll show you one other thing, and this isn't, I'm just going to start up the application, but this isn't particular to using the Spring Boot plugin. This is anytime that you use Cloud Native Buildpacks. But you can see that the code for the JVM memory calculator that was part of the Java build pack for Cloud Foundry has been ported over to the Cloud Native Buildpack. So you can leverage all of that intelligence of the memory calculations. Otherwise, if you're using a different tool, you're most likely just taking default JVM memory settings. So this is a big advantage of Cloud Native Buildpacks as well. And you can see that in action right here, right? So lastly, we're going to show you, I'll show you Kpack. So I've got Kpack installed in a Kubernetes cluster. So when you install Kpack, it installs these custom resource definitions. So you'll recognize these just as we have to tell, just as Spring Boot sets a default builder, or we told Pack what builder we wanted by default. Kpack also includes this concept of a builder that we can use to either name a builder or set a default builder. And it also includes the concept of an image, which is a way for us to tell Kpack, this is the Git URL where our source code is, this is the URL to our, or these are the credentials, and this is the target for our Docker registry. This is what I want you to build. These are the inputs and the outputs. So this has already been configured. So I'll show you that the cluster builder that we generated is pointing to the same builder that Spring Boot pins. So we're using the same version. So we know we're going to build the same result. And the reason it's a cluster builder rather than a builder, it just gives it a scope that's broader than the namespace that it's in. And then the image definition is right here. So you'll see that the image is saying, I want to use that builder that I called the default. These are the credentials so that it can log into Docker Hub and write the results there, upload the image. This is where it's going to get the source. So this is my app on GitHub. I'm pulling from the master. You could make this a jar file. You could make it pull from a specific commit, whatever you want to do, right? This is for the location of the target in Docker Hub. And the last thing I can do here, just to make sure that it triggers, is I'm just going to write a little bit of a change to a bump file in my Git repo so that I force a Git commit. And that might take a little time. I don't know if we'll catch it in time, but I refresh my Docker. Oh no, that's unexpected, sorry. So if I refresh here, so the last push was an hour ago. So it takes a little bit for Kpack to poll, but in the meantime, what we can do.
All right, Cora, 1 minute.
Okay, thank you. That's perfect. Thank you. In the meantime, what we can do is look at the logs for a previous build. So you can see how many times it's built already. And I'll pull the logs from a previous build. And okay, so here you can see that it's actually the same, right? The same kind of output that we've grown familiar with already, right? So it's another platform that's implementing that same lifecycle to get the same results. So we have that consistency all across. And let me see if we catch it in time. An hour ago. Okay, so it's a little slower. It takes a few seconds to pull. But in the meantime, I'll just go back and wrap up here. So to summarize, right? So Cloud Native Buildpacks are consistent. They're very easy to use, either locally or hosted as a service. They provide all of the bits and bytes, including the base image and all of the application dependencies that you need. to build your images. They support a variety of frameworks, very powerful. They build in best practices that are built upon 10 years of experimentation and experience with building images. They provide governance, transparency, and security, and they enable patching images safely and efficiently at scale. So with that, the last slide I'll show you is just a reference. If you want to repeat any of this, this is the app that I used for the demo. The README will talk you through building your image through all of these 4 mechanisms in case you're new to all of them. A course on Katacoda that'll walk you through Cloud Native Buildpacks for Spring Boot, for Kpack, for Kpack, and then all of the resources from the project itself. So that's it. Thanks.